When you have considering existing buildings and retrofitting existing buildings, what are the most important aspects of the technologies that you're talking about here that you suggest for those kind of projects?
So again, that's the other area we're starting to work more and more on. It's kind of like, again, we figure new buildings, we got that one figured out. Existing buildings, a lot tougher if you like. But certainly we've seen the same thing on that commissioning side. So typically when we're getting involved in existing buildings, the standard approach, if you have an existing building, is they say, oh, we're going to go and do an energy audit. And we've kind of soured on those a little bit. I mean, they're useful, but they're one step, and we've seen too many projects just sort of stop. We did the energy audit, we got the study, we put it on the shelf, we don't do anything. What we've been doing is saying we're going to combine the energy audit with recommissioning, because guaranteed that 25% I talked about, and Urban talked, 15 to 20% is guaranteed. Every building, there's that 20% savings we can get for no cost. We just got to find out where it is, and that's where the recommissioning will go out and find that. So we tend to couple those. So right off the bat, we can do 20%. Then, but if you like, the harder work comes of then looking for these technologies. Lighting tends to be a big one, and so on.
So going to your point about reducing the transportation footprint, rather than putting like behavioral incentives, have you tried in any of your projects engineering things that would facilitate cycling, more like indoor lockups or showers?
I'm sorry, I didn't show that. So in our office, but we have both bike lockers as opposed to, I'm not a big fan of bike racks. I think that's a cheat. Usually bike racks are empty and bicycles are strewn about corridors and lobbies and everywhere but the bike racks, okay? I think in our climate you need a bicycle locker that's protected the elements. So we have bicycle lockers, and as well we have shower facilities in our building so that you can then bicycle to work and take a shower. So that's what we've done. Yeah.
This goes back to the first question. I might have missed it, but how hard is it in existing buildings to put in those sensors that control the lighting and the heating?
Yeah. So I think after you do recommissioning, lighting is usually the next. Urban may want to speak to this. The next easy target. So typically, if you're going to an older building, it's going to be T12 technology. Fluorescent lighting technology has really improved over the last 10 and 15 years, so they're extremely efficient. And as well, of course, LED is the one that's sort of the one that's coming on the market. Not quite yet there, but pretty darn close. So, so once you're going and retrofitting the lighting, you would then want to put in the occupancy sensors, the daylighting sensors. I mentioned the DALI system, which is a very intriguing system, which gives you full control of that. So that would be number two. I don't know, Urban?
20% just do the monitoring of the building. 20% for free. The only thing you need to do is note down how much energy you use. That is number one. It doesn't cost you anything. The only thing that you do is just plug the holes. You know there's a hole, you know that something is going wrong. Plug it, fix it. Like you turned off the ventilation system that was running 24/7. It doesn't cost you anything. So you can get 20% for nothing, and that's every single building in North America. That's a lot of energy.
Anything else?
Anybody else? So you're measuring your energy use in kilowatt hours per meter squared.
Yes.
So does that incorporate like occupancy, electricity use per meters as well as heat?
Yes, it's all in, all energy. So. Per year. Yeah.
Is there any natural gas use in the building?
No, we're a gas-free building. So and I mean that was kind of an interesting. Sorry, I cut that part short, but I talked about the perimeter heating. So we had initially looked at putting in perimeter heating as a way of just sort of getting the chill off it, and that's where again we got this peer review done and. We have the heat pumps. We wanted to use the variable refrigerant flow heat pumps. Now, they're in essence air source heat pumps. And what happens is, the colder the outdoor air temperature, their performance really starts to die, okay? And so what ends up happening is you say, well, gee, I'm gonna have to put in a really big system because the performance on the coldest day of the year when I need my most heat is when they're performing at their first. So we thought, the only way we're going to get this technology to work is to put in some perimeter heating, which was going to be run on natural gas. Again, we had this peer review done, and the the fellow that did the peer review went and challenged us. He says, you know what, I'll bet if you put in darn good windows and you spent some time air sealing your building to get ventilation loads down, he says, I think those heat pumps could probably do it. And so again, we went back, did our numbers, did our calculations, and concluded that. So we said, okay, so let's get rid of the perimeter heating. So that saved us, it was almost between $200,000 and $300,000 in cost. And then we said, well, I'm only using gas for heating my water for my lab faucets. So that doesn't make sense. So, I mean, because normally I don't like using electricity just to generate heat. It's not a very good use of electricity. But then we said, well, hold on, if I do the heat pump, getting the waste heat from the server, I'm getting it pretty efficiently, and then I only need the top up. So then we actually said, well, if I'm not doing the water heating, I don't need the gas service at all. So we saved another $100,000 by not even having to bring the gas service in. So you started adding up all of these cost savings, and it was, you know, it ended up, we were saving a lot of money for not putting it in. Yeah. 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 Okay. Yeah. Yeah. Yes.
If you're using them for lighting, whenever it senses that somebody enters, the lighting is turned on, and that's fine. When you're using them for ventilation, for example, in the morning when people comes in, it takes a couple of minutes, or I don't know, probably 10 minutes, 15 minutes, when the ventilation starts to there is a delay for that particular place to be warm. So what has been, how it works?
Okay. Okay, so I didn't say this, but let me correct one thing. So we actually have what we call vacancy sensors, not occupancy sensors. So if you want the lights on in your office, three things have to happen. So number one is they're on daylighting sensors. So if the sun is up, the daylighting sensor is going to shut your light off. Okay. Second is you have to be in there. The occupancy sensor says you got to be in there to turn it on. And number three, there's a switch, an on-off switch. So if you want to turn your lights on, you have to physically get up and go over and turn the switch on. If you leave, the occupancy sensor will turn it off. So it's sort of manual on, automatic off. So and we think that's, it's hard to monitor the savings there, but we actually think it's pretty significant because there's a lot of people that just put in the occupancy sensors, and a lot of times the lights turn on and people say, well, I don't really need the lights on, but I got to get up and flick the switch to turn it off, and people are lazy and won't do that. So that's that. But back to the ventilation is, so again, typically we have, I don't know if you saw it, we have 6 energy recovery ventilators. Well, actually we have more than that, but the building's essentially divided into 6 zones in the building. If one person shows up in that zone, that will kick on that system. And we don't have ventilation per workstation. I mean, we have the nozzles, but in terms of fans, we've got 6 fans serving those zones. So the first person that comes in will actually turn the system on. And so, you know, when do you need your most ventilation is when the space is full. So you got the first person coming in. The other thing, of course, is why do I need the fan on? So typically your fan is doing 2 things. It's getting rid of contaminants from people. We breathe in oxygen and breathe out CO2, so we got to get rid of that, plus body odors and so on. So if there's nobody there, there's no odor, so we're not worried about that. The second one is to get rid of any kind of contaminants from the furniture that's in there. So I mean, the big one was formaldehyde from wood products, VOCs from a lot of the carpets and so on. So we chose to use all low off-gassing materials in there so that when you come in, you don't get that sort of stale smell in there of all these chemicals in there. So I'm not overly concerned, and I wouldn't say I've noticed that you walk in and it's stuffy or anything like that. There was no contaminants in there to flush out. Again, if you design your building wrong and you've got formaldehyde-laced wood in there and toxic this and that, yeah, you know, a lot of the plastics, PVCs, yeah, I mean, you got to get that stuff out. And so typically, again, conventional engineering practice is, oh, because I put the wrong materials in there, I have to start my ventilation system an hour or 2 below to flush that out. Well, again, wrong solution. Get rid of the chemicals that were the problem in the first place. Yeah, now we do, I mean, it does go into setback mode. So you can, if you if you came in on the weekend, or for that matter, the first person in, the building will be a little cool for that person. We only set it back a couple of degrees. First person in, the system comes on, within 15 minutes, it's up to temperature. It's 99% we're happy, right? Remember that? Yeah? Okay, no, and we joke, but seriously, that's, you know, ask the people. They're the ones that decide. Yeah, so there's not an awful lot of salvage materials. Keys Waters is one that I can think of. So I mean, they used to be called demolition firms, and now they're called salvage yards or recycling centers, and you know, the Habitat Restore and so on. They've rebranded themselves. So there is some of that. There's not an awful lot of salvage materials, and so part of what we were trying to do is, you know, in our own small way, start to create a market for that, and so it's. I always joke when you pick up, and I dare say you pick up the drawings and specifications for this building, I can guarantee probably on the first page of the architectural spec, it'll say all materials shall be new and free of defects, okay? So we just cross that sentence out. All materials shall be old and full of defects, okay? So again, I mean, and a lot of this is cultural. And I read an interesting article. I'm going to go way off tangent here, but I think this is key. Beautiful article about sort of consumer behavior and so on. And they were talking about the plastic garbage bag. I'm sorry, not garbage bag. The plastic bags we get at the grocery store. Okay, so you guys are all. It's not like this is a new story. It's only in the last couple of years. Okay, go back 4 or 5 years. You go to the grocery store and you buy, you know, eggs and milk and bread. They would automatically get your stuff, put it in a bag, and give it to you. If they said to you, would you like your stuff in a bag? Your immediate reaction is, I paid for these groceries. You put them in a bag, right? Okay, and so the clerk would just never ask you, okay? Now, as soon as we charged a nickel, and frankly, whether it was a nickel or a penny or a dollar didn't matter, the culture changed, and the clerk is now doing you a favor. Would you like to spend a nickel on the bag? And of course, in most cases, you say, well, no, I don't really need it. Not only that, the person in front of you has brought their little Zehrs cloth bags in there, and you're feeling really bad because you didn't bring yours. So you say, no, that's okay, I can carry them out of here, right? So the whole culture has changed from one of sort of I need it, or I deserve it, or I'm worth it, to getting it to, no, really, I don't want it at all. And I think it sort of goes to the same thing about lighting and ventilation and heating. We've set up this culture of what we want, and I think we've got to start redefining that.
To go back to the electric gas question, how do you handle the primary energy versus site energy in a province that's actually kind of got very polluting electricity?
Yeah, that's a tough one. The interesting thing is, yeah, that's right. So if you go back to Green on the Grand, the one we did in 1995, we were so just to get everybody on the same page. So I cheated a bit. I'm being caught out. I gave our energy use in kilowatt hours per square meter, which is called at site. In other words, I'm reading the meter on the outside of our building. Of course, that's not where the energy is being used. I got to follow that wire back, and eventually on the electricity side, I'll end up at a power plant. And that power plant, at least most power plants, are running at about 30% efficient. So they will use 100 units of energy to produce 30. So, and that's called source energy. So what a number of people have done is you take electricity and you say, well, I'm going to multiply your electricity use by 3 to account for the fact that really you cheated a bit because some of the energy was back produced at the power plant. Gas, the multiplier in gas is very small because frankly you just drill a hole in the ground and the stuff comes gushing out. Okay, we got to transport it, but it's fairly small. So when we had done Green on the Grand, we were very much concerned about this site versus source, and we tried to in fact do an all gas building. So it was gas heating, and we'd actually done gas cooling using an absorption chiller, and keeping the story very short, we were, what's the bleeding edge, or what's past bleeding edge? Yeah, we got cut. We bled really poorly or really bad. Technology didn't work very well, and we had to switch back to an electric chiller. But that was very much on our thought. Is we want to be concerned going all the way back. So we certainly had the same concern, and when we started the design, we had no preconceived notions of that we wanted a quote all electric building. But when we looked at it, you know, again, I think the example of the water heater I gave is, yeah, we could have brought the gas line in for the water heater, but you go all the way through it, and it just didn't make sense. So the interesting thing, so we've obviously run this building through the Energy Star database, and the Energy Star database does take your electricity use, multiply it by 3. Now, for most buildings, lights, cooling, everybody's going to get tarred with that same times 3. It's really only on the heating side where we pick up. So we end up, we're in the 99th percentile. I'm suspicious. I don't think you can actually get the 100th percentile. I think you're maxed out at the, so even though I accept your point that on source energy, our energy use is higher, but even using source energy, we're still in the 99th percentile. So I think we're okay. Yeah.
I was just wondering if you have any aspects of, like, if you consider or plan for deconstruction or modular building at all?
Interesting question. So this is, in fact, I wrote an article on that one too. So there's, among the architectural community, they say, well, look, if we're talking about minimizing energy, there's the energy used by the building, and then there's the energy used to make all the materials that go into your building. And you get into these arguments, well, gee, insulation saves energy, but I had to use energy to make the insulation. Am I ahead of the game? Right? I could actually be losing energy hand over fist by trying to save it. Okay, that goes the argument. So some studies have been done to look at this, and I'm going by memory. I'll be off a little bit, but the premise is the same. The amount of energy used in the materials represents about 2 or 3 years of operating energy. So given that a building is going to be around for at least 30, 40, or 50 years, the operating energy swamps the energy used in the materials. That's not saying to be wasteful there, but let's not get into this game of, well, I didn't put insulation in because it requires energy to make the insulation. Bad investment decision, okay? So generally, you're going to try to get that operating energy as low as possible. So did we look at decommissioning or the deconstructibility? To be honest, not really, and part of it was that. Now, we have done some projects where to the particular owner that was important. Mountain Equipment Co-op would be a good one if you ever go to there and see that. They tend to build wood frame structures, bolted connections, so it could be you know, disassembled, if you like. So yeah. So that, again, ties very much into this, it's called the embodied energy of material. So the embodied energy includes the energy to make the material as well as the energy to transport it to where you are. And so actually under LEED, there's points associated with doing that. And so we score, I can't remember the number, we scored very high under that credit. Having said that, I think its value is overweighted in the system. Again, if I can get a really energy efficient heating system from Japan, I'm pretty darn sure I'm ahead of the game shipping it all the way across the ocean to get it here. I'm not saying to ignore it, but I'm saying just make sure you keep it in context. Yeah.
This might be a little bit outside the scope, but it relates very much to these questions. Are there embodied emissions that are factored into the greenhouse gas inventory that are done by, say, yourself or other companies? When they're building an inventory, say, of the building, are the embodied emissions factored into that inventory?
So you can do it. So there are programs where you can say, I used so many tons of concrete and so much PVC and steel and so on, and it will spit out. You know, if you followed all those materials back, how much, well, greenhouse gases, how much water, yeah, all of those things. So you can do that. The program's called Athena, a great program. We did not use it to do this. Again, it takes an awful lot of time and effort to do that. And at the end of the day, at least whenever we've done it, because you get into these big debates, should I build my building out of concrete, steel, or wood? And at the end of the day, when you go through it all, the difference between the three of them and the various emissions is fairly modest. And so I tend to find there's much more important things. I'm not discounting their work. I think it's great work that they do, but we don't use it much. Oh, and there's no. So they're just doing operating energy. So it's your utility use. Obviously, transportation is operating, and then when I said materials, it's the paper for our photocopiers and that sort of stuff that we track. we think it's pretty typical to everyone. I mean, it's interesting. I have this little joke I use is, you know, generally in the sort of commercial construction, everything comes down to cost. They say, oh, you know, that's all they care about is cost. And so I say, well, since you're so concerned about cost, I've got a great value proposition for you. You should go into the house building construction, okay? And we all know that an operable window costs more than a fixed window. So build your house all out of fixed windows. And in fact, you know, windows cost more than walls. So don't put any windows in. You'll have the cheapest house on the street. You'll make money hand over fist, right? No one's taken me up on this yet, I might add. But see, there's the point, is because it's the consumer that has the money in their hand, they look at that and say, I'm not going to live in that thing, I'll pay them more money. When we get into commercial construction, all of a sudden we've done a disconnect between the people that are in it and the people that are paying for it. And that gets back to that whole about designing it for people and productivity and so on. So I think the more, and that's why I think this occupant survey is really important, so that owners and building operators and so on, you know, presidents and CEOs can see what this really means. And so I think that's a big part of it. Now, that didn't answer your question at all. And I've forgotten the...
No, I was just wanting to ask if the benchmarks differ.
Oh, for hotels, sorry, yeah. So the thing I was saying about hotels, guess what? Hotels kind of got this too, because hotels, I mean, how many times have you gone into a hotel room and it doesn't have a window, right? You know, we got a great interior hotel room for you, right? We do it for office buildings, we don't do it for hotels. So I'm just saying, so hotels, because they know they're in the selling business, realize they don't have to do that. Sorry, that was a tangent. So in essence, I mean, the technology is going to vary when you move from building type to building type. But when you go and look at energy use of hotels, it's on par with office buildings. It's not that far apart. Most buildings tend to be in that, you know, normal buildings in that sort of 300, 400 range. Hospitals are about twice that number. They would be the one outlier. Data centers would be another outlier. But all the rest are about in that same range. Really, it's all the same technologies that are in there. So there's no reason you couldn't use them. Yep.
I know it's maybe a little hard to measure, but like, has that company culture permeate to the employees right away, like their energy bill, right?
Yes.
I know that's hard to say, right?
Yeah.
But do you feel that actually is changing the way in their own houses, right?
Yeah. Well, I briefly went through that green incentive program, so I don't know if you caught on there, we actually have incentives for the people's individual houses. So if you make an energy retrofit to your house, we'll match, I mean the government canceled the program, but we match the government contribution as just part of our service.
They're taking part of it.
Yeah, now, the other thing I will say, talk about, this is kind of like the grocery bag thing again. So again, we give incentives for hybrid vehicles, we have preferred parking spots. If you have a hybrid vehicle, you can park by the front door and so on. So one of our employees, their car had to go into the repair shop and they had to borrow Dad's car to come to work. Well, Dad drove the Escalade, right? So puts it in he puts it in the parking lot. Somebody else from it goes and takes a picture of his car and puts it in the kitchen, and it was like, you know, world killer, baby killer, you know, this sort of thing. So needless to say, that's the last time he borrowed Dad's car to go to work. So yeah, so there's some of that there. So.